Hello everyone, this is video number 3. I want to start this video with the following example. Let's assume we have y and x axis, okay, and also we have 3 points that belongs to linear function. This coordinate will be 0, 0. This is second point where x equals 1 and y equals 2, and the third point where x equals 3 and y equals 4. Okay, first coordinate, second coordinate, and the third one. Okay, and we know that all those points belong to linear function. What I want to do next is calculate the next ratio, delta y over delta x. Now, what is delta? Delta is actual difference between the 2 points. Okay, delta y is actually y2 minus 1, 1. The same goes for x, delta x, x2 minus x1. Okay, so from here we have that delta y over delta x equals y2 minus y minus y1, x2 minus x1. Okay, soon we will understand what this ratio means. Okay, let's assume that the first ratio that I want to calculate, first of all I want to let's mark this expression. Let's mark delta y over delta x as a m parameter, okay, which means that m equals delta y over delta x. Now, the first ratio that we will call it as m1 equals y2 minus y1 divided by x2 minus x1. Now you see that we actually need 2 points where the second point is x2 and y2. This is actually our coordinates, and x1 and y1. This is our first coordinate, and we need to choose 2 coordinates to calculate this first ratio. Let's assume that I actually want to choose the following 2 points or coordinates. First point will take 0, 0, and the second point 1, 2. Second coordinate. Okay, this is point or coordinate x equals 1, y equals 2. Okay, from here this difference we call it as delta y, where delta y equals 2, which is this point, minus 0, this point, this value of y. The first value of y and the second value of y, and we make a difference. We calculate the difference, I'm sorry. Okay, the same goes to x. Okay, delta x equals 1 minus 0. This value. Sorry, this value. Okay, therefore m1 equals 2 minus 0 divided by 1 minus 0. We have answer, which is 2. Okay, the ratio between those two coordinates, okay, is actually 2. Okay, let's take different coordinates for our last example. Maybe this time I'll take those 2 points, okay, which the first point or coordinate is 1 and 2. The second coordinate will be 3 and 4. Maybe I'll just copy this and paste. Okay. The second ratio, m2, equals, as I said a few moments ago, this will be our first coordinate and this will be our second coordinate. Now if you see, delta y between those two coordinates, it's actually difference between 4 and 2. This is delta y equals 4 minus 2. Delta x equals 3 minus 1. Now we can calculate the second ratio. m2 equals 4 minus 2 divided by 3 minus 1. And we get 2 divided by 2. We have 1. Wait a minute. How come I have here different value? Oh, I'm sorry. There is a mistake. It's not 3, it's 2. It equals 2. Okay. It's 2 minus 1 equals 1. 2 divided by 1. And we get the same result as in previous calculation of the ratio. You see that m2 equals to m1. And the last ratio that I want to take may be this point and this point, okay, or coordinates. Again, let's copy the picture, the graph of this example, and we want to calculate the third ratio, m3, and we'll take this will be the first coordinate and this would be the second coordinate. Now if we want to calculate delta y, we have to take this second y, which is 4 minus 0. These are the delta y. Delta x is equal 3 again, it's not 3, it's 2. Sorry about that. Okay, 2 minus 0. And now eventually we can calculate third ratio, which is 4 minus 0 divided by 2 minus 0, and we have the same result. Now you can take infinite possibilities to calculate ratio. You can take any 2 points or coordinates that will belong to this linear function, any 2 points, first, second, first, second, first, and you have infinite possibilities to take infinite ratios, and you still will have the same result for the ratio. Now when you see this, and mathematicians also notice that, they say, wait, we know that the slope is actually something that is constant, and the ratio between those 2 points that we take also constant, and therefore we have our first definition for the slope. M, it is actually a slope of a linear function, that defined as ratio between delta y and delta x. This is our slope. Okay, actually, if you remember, for our first video we got this expression y equals 2 times x. Okay, and this number 2 was actually your magic, or something that you could do to the first group that was independent, to create second group y, which was dependent on group x, and you applied your magic to create second group. So in this case you can say our magic is actually a slope of this linear function. It's your function that you applied on the independent group, okay, to create dependent group, which is y. Okay, so your magic, okay, or your function that we created in our first video was number 2, which is the same in this example, in this video. If we speak freely. Okay. The last thing that we need to do is to build general expression of a linear function. Now, how we can do it? Okay. What I want to say, let's assume that I can take one of those points and this expression of slope. No, let's rewrite this again. Slope m equals y2 minus y1 divided by x2 minus x1. Let's assume that you can take this coordinate x1 and y1 and you can fix it, which means this point or coordinate will not move. What does that mean? It means if I will draw this graph of some function, linear function, this is x and y, let's assume you have, I don't know, a linear function like this with constant slope. Of course you can take any point, that belongs, of course, to this linear function, any point, and you can call it as a fixed point, which means it's your reference point that will not move, and you can call it x0 and y0, not cola 0. Okay, x0, y0, and this point won't move. It's like your reference. Okay, it's something that you begin with to build a function. Second point that is mentioned as y2 and x2, okay, this point actually can change its position. It's like variable point. You can vary the position of x. Let's assume that this second point can move right or to the left. Okay, let's assume at some point your x actually here. For this x, of course, you will have exactly one y. For another x, of course, you have another y, which means this point can move, okay, can travel like this. It's a variable, which reference will be this point, x0 and y0. And for every position of this variable, x and y, even it's here, 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 or any point you want, at any point that you will put this coordinate, okay, and you want to calculate the slope, which is delta y. In this case, it would, you will see this expression as y minus y0, and delta x is x minus x0. Then you have your slope y minus y0 divided by x minus x0. Okay, and of course this expression is equal to this expression as long we are talking about this linear function, because you can write any other point, y3 minus y2 divided by x3 minus x2 equals to y5 minus y1 divided by x5 minus x1. Okay, you know what, even we can always calculate the slope where x1 and y1 won't change, and this point we can call it now as a fixed point, x0 and y0. Now I can write this expression of slope as y minus fixed point y0 divided by x minus x0. Also, this is a fixed point. This is your variable. And the ratio between them is a constant, which is a slope. Now let's multiply this expression by x minus x0. And what we will get? M times x minus x0 equals y minus y0. Therefore, y equals m times x minus x0 plus y0. And that's it. That's what you see here. This is actually a general expression of a linear function. It's like a formula for linear function. Of course, now we need to do some examples. But before that, what do we need, okay, as a um, goal, okay, maybe you can say that, to find a some private expression of linear function. This is general expression, okay. What do we need to find linear function? One, we need 2 points or 2 coordinates. Okay, this is one, because if you have 2 points, okay, let's draw this fast. Oh, not that fast. Y and X, and let's assume those 2 coordinates are given and we are talking about linear function. It's enough 2 points to draw a straight line between them here. Now if we know this x1, y1, and this second coordinate x2 that bring us to y2, of course now you can calculate the slope, because you can calculate delta x, and to find delta y, from here you get your slope m equals y2 minus y1 divided by x2 minus x1. Now we know how to find our slope, which is the same slope that you can put in this formula. And if you know those 2 points or coordinates xy, x1 and y1, and second coordinate which is x2 and y2, then you can choose from those points you can decide which of one of them will be as a fixed point, which means is x0 or y0. Okay, this is one possibility to find a linear or expression of a private linear function. Second possibility to find a linear function or expression, a mathematical expression for a linear function, okay, you need 1 point as a given point and a slope, because this 1 point will become as a fixed point of a linear function, and a slope. This is the slope. Okay, example. We know that we are talking about linear function, and we have 2 points, 2 coordinates are given. Let's say a equals to x1 equals -1 and y1 equals -1. Also the second coordinate, we call it b, x2 equals 2 and y2 equals 2 also. Now, because I know that we have 2 points, 2 coordinates, of course I can calculate the slope m, which is given by this expression of delta y divided by delta x, okay, which is y2 minus y1 divided by x2 minus x1, okay, 2 minus 1 divided by 1, sorry, minus, oops, The screen is jumping. -1. No, sorry, again. x2 is actually 2 minus -1. So what is the solution? For the slope 3 divided by 3, we have 1, which means slope equals 1. Now we found slope. Okay, if we use this expression y equals m times x minus x0 plus y0, where m equals 1, the last step we need to do is to choose which of those points that were given, okay, will be our fixed point, x0 and y0. Let's assume that our fixed point x0, y0 is a, which equals to -1, -1. Let's insert this fixed point in our general equation for linear function. Also, we will insert this slope in this equation. Let's see what we will get. Y equals 1 times x minus -1. Okay, this is our x0 plus -1. This is y0. Therefore, x plus 1 minus 1 plus 1 and -1 terminated, and we have y equals x, and this is our first private linear function, private solution for our given information about this linear function, which was 2 points. Now, of course, you could take a second fixed point, not A, but B, okay? X. Let's check if we will get the same result if we would take B as a fixed point. And what it was? 2. Oh, some bugs on this. Wait. Oh, come on. 2 and 2. Okay. M still equals 1. The slope is still 1. Okay, so y equals 1 times x minus x0. x0 is 2. Plus y0 is 2. Equals 2. Therefore, y equals x minus 2 plus 2 those two terminated, and again we have y equals x. Okay, it doesn't matter which of those points you choose, because also a and b are belong to the same linear function, to the same line. Okay. Second example. we have fixed point already, 0 and 1, and we have a slope m equals 3, and they want to find us what is the private linear function. Okay, what is the expression of the private expression of a linear function that the slope of this linear function is 3, and this point is belongs to this linear function. Okay, so we know the formula for general linear function. Okay, we can insert all the information. M equals 3, x minus x0 equals 0, and y0 equals 1. Therefore, we have that y equals 3 times x plus 1. And that's it. That's how you can build a linear expression of a linear functions. Okay. Now, in next video, of course, we'll do some more examples. But at this point, I'm gonna stop this video, and I'll see you in the next video. Bye bye.